Okay, so the first property is multiplying. Alright, so here's a couple examples. First example we have here is 7 to the third power times 8 to the negative 8th power. When multiplying like bases, can anybody take a stab and say what you think you would do with the base and the exponents? Yes?
Well, since the exponent in 7 to the negative 8th power is negative, would you do 7 over?
You could. If you look at the first property, it says to multiply two numbers with the same base. First off, do these two have the same base? Good. My base is 7. They both have the same base here. To multiply numbers with the same base, what do? What's that next phrase?
Add the exponents.
Add the exponents. Okay, so I'm going to keep my same base, so 7, and I'm going to add my exponents. So I'm going to say 3 plus negative 8. And this is going to give me an answer of 7 to what power? 3 plus negative 8.
7 to the negative 5th power.
Excellent. 7 to the negative 5th power. And I want to change this now. I don't want to keep a negative exponent. How do I rewrite this with a positive exponent?
1 over 7/5.
Excellent. So this becomes 1 over 7 to the 5th power. Next example. 6 to the 20th times 6 to the negative 6th. Again, ask myself, or ask yourselves, do you have the same base?
Yes.
Yes, so this becomes 6 to the 20th plus negative 6 power. And I got an answer of 6 to what power?
14.
Excellent. 6 to the 14th power. The exponent is positive. Leave it just the way it is. Beautiful. And last, 6 to the 5th, c to the 5th times c to the 3rd. Okay, now we're going with variables. Same concept. Do I have the same base? Same base. Excellent. My base is c. c to the 5th, c to the 3rd, add my exponents, c to the 8th. Questions so far? Okay, let's look at the next example. Multiplying, we add the exponents. Dividing, what do you think we do with the exponents when we divide? Excellent. When we divide, we subtract. So we have 7 to the 4th divided by 7. 7 to the 4th divided by 7. Now the second 7 here doesn't have an exponent. Yep.
Isn't it immediately 1?
Excellent. It's unwritten 1. Okay, so if there's no exponent there, we're going to assume it's 1. Keep my base, 7, same base. And like you said, subtract the exponent, so 4 minus 1, and this becomes 7 to the 3rd power. Next one. 9 to the negative 12th divided by 9 to the 3rd. 9 to the negative 12th divided by 9 to the 3rd. Do I have the same base? Everybody?
Yes.
Yes, excellent. So keep my base 9. Negative 12 minus 3. Now this is where you have to be on your toes with your integers. Keep my base 9. Negative 12 minus 3. Excellent. Negative 15. So this is 9 to the negative 15th power. How do I write this with a positive exponent?
1 over 9 to the 15th.
Excellent. 1 over 9 to the 15th power. All right, let's take care of the one with the variables. X to the 7th over x to the 10th. X to the 7th over x to the 10th. So again, this is still division. Do I have my same base? Okay, so this is going to be x to the 7th minus 10, and I get an answer of
X to the negative 3rd.
x to the negative 3rd, and x to the negative 3rd can be written as
1 over x to the 3rd.
excellent, 1 over x to the positive 3rd power. Questions on dividing? Okay, so far so good. Not bad. Not too bad yet. Okay. Another example we're going to have is a power raised to a power. We have a power raised to a power. So if you notice, here's my exponent, 3, and it's raised to another exponent. So when we multiply, what did we do with the exponents? When we multiplied, what do we do with the exponents? When we multiply bases,
You divide?
with the exponent, when we multiply, we
Add.
add the exponents. When you divide, what do? Now you subtract. Multiply, we add. Divide, we subtract. A power to a power. Take the base and multiply the exponents. So this becomes 9 to the 12th power. 9 to the third raised to 9 to the fourth is 9 to the 12th. Another way to look at this is like saying 9 to the third times 9 to the third times 9 to the third times 9 to the third. If I'm multiplying my like bases, what do I do with the exponents? If I'm multiplying with like bases, what do I do with the exponents? Add them, so this would be 3 plus 3 plus 3 plus 3, which is 9 to the 12th. But rather than doing that, we're going to take a shortcut and just multiply the powers. So it should be 9 to the 12th. X to the 7th raised to the second power, or squared. Yes? Excellent. Multiply 7 times 2. So this is x to the 7 times 2, which is equal to x to the 14th power. Very good. How about a to the 6th raised to the 1/2 power?
A to the third.
Excellent. So this is a to the 6th times 1/2, which is equal to a to the 3rd power. Very good. So again, when we multiply, what do we do with the exponents? When we multiply, what do we do with the exponents? Add them. When we divide, what do we do with the exponents? Now we subtract. A power raised to the power, what do we do with the exponents? Multiply. Excellent. Another example. A product raised to a power. A product raised to a power. So I have two numbers inside my parentheses being multiplied. There's my product. Now the product of 3 times 2 to the 4th power is raised to the 3rd power. So that's the product raised to the 3rd power. Each one of these numbers inside the parentheses are raised to the 3rd power individually. So this is the same thing as saying 3 to the 3rd power times 2 to the 4th to the 3rd power. Okay, I'm giving the power to both of them. It's like I'm distributing that exponent to both numbers inside my parentheses. 3 to the 3rd power stays as 3 to the 3rd times 2 to the 4th raised to the 3rd power becomes what? Excellent, 2 to the 12th power. And if I want you to evaluate these, I will ask you to, but so right now, just leave them just the way they are. Next example. xy to the 4th, all raised to the 3rd power. X times y to the 4th, all raised to the 3rd power. Okay, so again, you're distributing the 3 to both of these. So the first one's like x to the 1st raised to the 3rd power times y to the 4th raised to the 3rd power. Now again, this is an extra step I'm taking to write these down. It's a good idea for now. Once you get used to it, you don't have to do the steps. All right, so this is x to the 1st raised to the 3rd power, and I wrote it here. Y to the 4th raised to the 3rd power, and I wrote it there. Now, if x to the 1st raised to the 3rd, what do I get when I have this one? What's my outcome? X to the 1st raised to the 3rd. This one here will be x to the 3rd. And then this one, y to the 4th raised to the 3rd. Y to the 12th. Excellent. Multiplying 4 times 3 to get my 12. Multiplying 1 times 3 to get my 3. Okay, next one. Careful with this one. A to the negative 2nd b to the fourth. So again, this is like saying a to the negative second power raised to the negative third power times b to the fourth raised to the negative third power equals what? What do I get with my a's? A to what power? A to the negative second raised to the negative third. Excellent. Negative 2 times negative 3 is positive 6. Excellent. Times b to what power? B to the fourth raised to the negative third power. Excellent. B to the negative 12th. I don't want negative exponents. How can I rewrite this?
A to the 6 over 1 times 1 over b.
Okay, so this is like a to the 6th over 1 times 1 over b to the 12th, and I can combine these and just get a to the 6th over b to the 12th. Questions so far? Okay, let's take a look at another example. Two more. One more, actually. One of the easiest ones. One of the ones you have to love. The zero exponent. The zero exponent. A to the 0 power. A to the 0 power. What is a to the 0 power? Excellent. 1. What is 5 to the 0 power? What is 5 to the 0 power? 1 again. The product, x times y, all raised to the 0 power. The product, x times y, raised to the 0 power.
1.
1 again. Alright, anything raised to 0 power is just simply 1. Questions?